Welcome to my channel once again.
Dr. Asadi Srinivasulu.
Machine learning techniques for image classification.
So these are the libraries. Now I'm going to do practical sessions on the image classification using machine and deep learning algorithms. What are the challenges of deep learning? See here, learning without supervision is a challenge. Coping with the data from outside the training distribution is a challenge. Incorporating logic is a challenge of deep learning. Unsupervised and self-supervised learning, it is a deep learning challenge. Autoencoders, it is a challenge. To overcome these challenges, we are using a combination of frameworks like Keras, TensorFlow, PyTorch, Piano, Matplotlib, sklearn, scikit-learn, various libraries we are using in order to avoid these challenges. Then deep learning challenges like high performance hardware requirements, issues with flexibility and multitasking, data availability, non-optimizing hyperparameters, data security. These are the deep learning code libraries: NumPy, SciPy, scikit-learn, Piano, TensorFlow, Keras, PyTorch, Pandas, etc. Python libraries and frameworks. Machine learning. See here, NumPy. What are the libraries we are using for machine learning? NumPy, TensorFlow, Piano, Pandas, PyTorch, Keras, scikit-learn, Matplotlib, SciPy, Seaborn. Then web development tools: Django, Flash, Bottle, CherryPy, Pyramid, Web2Py, TurboGears, Cubic Web, Dash, Falcon. Automation testing: PyUnit, Behave, Splitter, Robot, PyTest. Image processing: they're using OpenCV, Maho, Mahotas, Busy Magic, Simple TK, Scikit-image. Game development: Pandas, 3D, Pygame, PyOpenCL, Pyglet, Arcade, Web Scraping, LXML, and Request, Selenium, Selenium, Beautiful. These are the tools. NumPy, SciPy, Pandas, scikit-learn, Piano, TensorFlow, Keras, Python, Seaborn, Matplotlib. And these algorithms KNN have executed. Now healthcare application, especially our core topic, digital images. Okay. So healthcare is the maintenance or improvement of health via the prevention, diagnosis, treatment, or amelioration or cause of disease, illness, injury, and other physical and mental impairments in people. Healthcare is delivered by health professionals and allied health. Efforts made to maintain or restore physical, mental, or emotional well-being, especially by trained and licensed professionals. These are the 7 image database applications I am going to demonstrate now. COVID-19 virus prediction and detection, Omicron virus prediction and detection using machine learning and deep learning, Ebola virus prediction and detection. I have taken X-ray and CT scan images for all these 7 image database applications: prostate cancer prediction and detection, breast cancer prediction and detection, lung cancer prediction and detection, monkeypox virus prediction and detection. So 10 healthcare applications that you can build without coding, like online patient portal, disease management, patient condition reporting, health and wellness management, diagnostic. inventory management, research and development databases, digital transformation and productivity, knowledge-based system, and the laboratory management. So now I'm going to explain image database application, especially COVID virus. Coronavirus is an infectious disease caused by newly discovered coronavirus. COVID-19 is caused by a coronavirus called SARS-CoV-2, severe acute respiratory syndrome. COVID-19 is a disease caused by new strain of coronavirus. CO stands for corona, VI is for virus, and T for disease. Formerly, this disease was referred to as 2019 novel coronavirus. That's why it is called COVID-19. These are the symptoms of COVID-19: fever, cough, shortness of breath or difficulty, breathing, chills, muscle pain, headache, sore throat, new loss of taste, congestion or runny nose, nausea or vomiting. So these are the clinical and image features of COVID-19 patients. Data set I have taken. Nearly 850 images I have taken, X-ray images. Then I have applied convolutional neural network. Step 1, convolution operation. What is the meaning of convolution? It refers to the combination of two functions to produce third function. Produce third function. You can call it as third function. And see, next, convolutional ReLU layer. So ReLU layer, rectified linear unit. That is a rectified linear unit. Is activation function to compute and predictable gradient path propagation of the error. Increases the linearity function that are context of convolutional neural networks. Pooling, it reduces the spatial size of representation and to reduce the amount of parameters. And also computation in the network, there are two types of max pooling and min pooling or average pooling. Flattening, it is converting data into one-dimensional array for inputting to the next layer. It will flatten the output of the conventional layer to create a single long feature vector. Step 4, it is to take reserveful connection. It is to take the results of convolutional or pooling process and then to classify the image of a label. So these are the 4 steps we are following precisely: convolution operation, pooling, flattening, full connection. So these are the steps I am following COVID-19 image classification. Feature extracted by transfer learning in Keras and Syllabus.
Thanks for watching. Please subscribe.
This is problem definition, data preparation, feature engineering, training ML algorithm, testing, trained model deployment, etc. This is the input I have taken. Normal image. COVID-19 image pneumonia. I am giving input to the system. System has to recognize which image is, whether it is COVID-19 or pneumonia or normal. By using exception network and REST-like 50. Parallel deep feature extraction. They are using concatenated features. And finally, we are predicting normal or good. This is the corona virus training data set to the CNN. These are the X-ray images I have taken as input to the system.